Hello coders, welcome to my channel. In this video, we'll discuss about one of the IPC technique that is called pipe. Okay, so what is IPC? As you already know, that is the inter-process communication, and these are related to the processes which are running in our system. So every process that is running in our system is independent of each other. Okay, so if we want to communicate within the process you need some IPC mechanism. So this pipe is one of the simplest form of IPC that is being used. Okay, so these are the very important points. So pipes are the system calls. Okay, so it operates throughout the kernel. Okay, so pipes are used in unidirectional communication. Okay, so if one process is reading, so other should be writing only. Okay, it's not like the multiple processes can communicate bidirectionally at the same time. So been used between the relative process. So what do you mean by that? It means that a particular relation should be there between the two process. For example, one is child, one is parent. Okay, or that the process is the successor of that process that is calling that pipe. Okay, so there should be some linkage between the process. Two independent processes cannot communicate between each other. This is because we don't have any file system entry of this pipes in the user space. Okay, so we have the blocking behavior of the read and write on the pipes. Okay, so the when you reading something from the pipe, if it is not there, the read will go into the blocking state. Okay, so your program will hang till we write something on the. So there are two ends of the pipe. One is a receiving end, and second is the writing end. Okay, so the one reading end needs the writing end to write something on that pipe so that the reading end will read it, and the same vice versa. Okay, so this is pipes memory is implemented in the kernel space. So it's not a user space process like we have seen in the file system where we are writing some data in the file and we are reading it. So that is from the user space. But here the memory that is created when you call the pipe system call, will be in the kernel space. Okay, so we are writing and reading through the kernel space as well to make the fastest access of that memory. Okay, so let's see how pipe is being used. So first, the system call is pipe, pipe. Okay, so they have one input. So what is that input? There may be two descriptor that will be created by the pipe. So we will be taking fd. We'll take this array and mark it 0. Okay, so this array should be the input to this pipe. Okay, so once you do that, we have two integer values, two file descriptor. So fd0 and fd1. Okay, so fd0 is used for reading the pipe and fd1 is used for writing the pipe. Okay. So we can take the return value as well. So if this is equal to -1, so pipe is failing, we're unable to create that entry. So we'll do one thing, we will have this printf simple here, and we'll say error pipe not created. Okay, and then I will exit from here. Okay, or I will take that exit failure macro over here. So it will return. Okay, so the header files you need to include for the system call is, I will take uni std.h and hash include stdlib dot h for exit. Okay. So once this pipe is created, I will have two file descriptor. Okay. So let's take it printf. I'll just print first. Okay. So fd 0 is percentage d, comma fd 1 is percentage d, and here I will print fd0. So fd0 is for writing, sorry, reading. Fd1 is for writing. Okay, so what I will do, I will create a child process out of this process. So I have to use a fork system call. Okay, so as you have seen in the last videos, I will use the fork, and it will create PID underscore PID. Okay, and what I will do here, if PID is less than 0, it means this thing is failing. Okay, so I'll print a message over here that will say printf failed to create process. Okay, so I'll take the next line here as well. Okay, so next I'll take exit from here as well. Okay, so I'll copy this thing. Okay, and then I need to check for the child process. So if PID is equal to 0, then say child process. You have to do something here, else it's a parent case. Okay, and in the last I'll print program is closing now. Okay, and here what I will do in the child process, so I'll mark it as well, I think. So it's a child process, and this is a parent process. Okay, so till now I have two descriptors. So these two descriptors is shared between the process child and the parent process. So what I will do, I will write something from the child process and print it on the parent process. Okay, so I will take a string over here. So let's take here only. So I will take const character string buffer is equal to hello from the child, because this child need to be sent this value. Okay, so here what I will do, so I have two descriptors here. So in this process, in order to remove any error from the read descriptor, what I will do, I will close the read descriptor, and then what I will do, I will write on fd1, that is the write descriptor of the pipe that we have created, and here I will put the buffer, and here we'll put the size of the buffer. Okay, I'll take uh, write bits bytes. Okay, and I will print it here. So printf write bytes are percentage d and comma, and we have WR VIPS. Okay, so this is we are writing on the pipe. Now we have to receive from the pipe. So what I will do, I'll just make it read bytes, put it read here. Okay, then here I have to read, so I have to take from here. So buffer I have to create, so I will take buffer underscore read. Here also R, and here I'll take a buffer as well to read it. So char buff read. I'll take random 100 bytes over here, clean it. Okay. So now I have to close the write descriptor over here so that it won't interfere with the other file descriptor or wrongly we're not accessing this file descriptor as it is this unidirectional. Okay, so here I write read bytes are this. Okay, so what we are doing right now, we are creating a file descriptor from the pipe read and write. Okay, then what we are doing, we are creating a process. Then we are checking the child process, writing from the child process to the parent process, and we are closing the program. Okay, so let's see what will be the output. Are not getting the correct string. Instead, we get some part of that string. So program is closing. Okay, so both the process, parent and child is closing, but it's not making the correct bytes. Okay, so let's see what's the problem in our program. So here we have the buffer. So if we go to the buffer where we are using, okay, so we are writing on every one buffer and size of buffer. Okay, so so here I think this pointer we are using. Okay, so the size of the pointer is 8 bytes. So that's why it's taking the 8 bytes. So we need to take string length over here. Okay, so let's check if we read it directly. Okay, so this is we have to add string length library. It is spring.h. Okay, let's save it again and then again write it. Okay, okay, now I'm getting the correct data. This way, this pipe works. Okay, so let's see in the next video. Yes.